Okay, so yeah, here we go. Threading the one yesterday. What was the other? Um, Threading is gonna make it faster. This scans just one port at a time. Threading is gonna make it so we can scan almost like a section of ports all at once. So like we could scan port 1 and 100 at the same time. It could happen at the same time because it's with this threaded script or whatever. Oh, I think it just slipped out. I don't know. I just had it. I just forgot. Oh, because they're both parallel. I mean, because it's scanning parallel. That's like kind of how Claude described it. But low key, that sounds kind of confusing. Parallel instead of looking at it like a section, but whatever. Whatever. All right. So yeah, that's what we're gonna do. This is yeah, the first one that was slow that we did yesterday. I just wanted to like say that, I guess. So I just have my notebook here. I don't even think I'll need it though, but we'll see. Because I need my keyboard. So all right, yeah, because we are gonna type it out. I'll probably just cut some of the typing out. Oh, I see. Okay. And then it explains it here. So parallel doesn't mean ports that are side by side. It means happening at the same time. So regardless of which ports they are, like I said, port 1 or 100, they could be scanned at the same time. Port 1 and 800 could be scanned at the same time. It says, think of this version here as one person checking 1024 doors at one time, walking down a hallway. Yeah, one at a time. Yeah. 1000 doors, one at a time, walking down a hallway, versus sending 100 people down a hallway, and then they can all open. Some doors are going to open at the exact same time. Okay, yeah. So like I said, this is a upgraded version of the first this one here. So just gonna start, bro. First time using ThreadPoolExecutor. Yeah, first time using this. So yeah, this time, I mean, on this video, I'll probably actually like cut more, and then when I'm talking sometimes, while I'm just typing out this, I'll cut in, because yeah, this seeing the whole script at once before I type it is cool. Okay. Bro, did I miss? Oh yeah. Oh, like, did I miss something? Of course I did. Like what? Okay. I did glance at the bottom and I was like 2 to 3 problems. I'm like, what the fuck? I'm like, I know I did something wrong though. I just I don't know. Whatever. Target from result sock dot. Okay, so basically, we have some. I want to type a little bit before I actually maybe said some sentences that made sense. So we have this. Well, this is an upgraded version of the original script, which is this, right? And and why is because ThreadPoolExecutor allows us to check many ports at once instead of one at a time. We have some other stuff that is going to be critical, but why is there? Because there's nothing with it yet. LOL. Because with all right. Some other stuff that's going to be important to say right after this with, but I just wanted to stop and talk about start being assigned to this time, because that's something. Yeah, import time is something that we're adding new to this, and we're also gonna add it into here. I just haven't did it yet because I want to go ahead and start. Okay, so yeah, I need to go over a couple topics that I need to remember. Printf, or an f string, is a string prefix that lets you embed variables directly inside a string using curly braces. Okay. It's the short version of how they used to do it. It's basically the only way I'm about to explain that. The F just tells Python, hey, evaluate anything inside of those, curly brackets. These. Okay. Then I needed like a reminder on for loops. For loops is what, yeah. So just put an example on the screen since, of course, I have one. This runs scan port, one port at a time in order, waiting for each one to finish before starting the next. That's why it was so slow. Our original, that's why this is so slow. Okay, so we're starting here. I just pasted the rest because with, yeah, it wasn't that much left. So yeah, I needed a reminder on f strings, for loops, just to remember. I probably still need to do more actually. But anyway, we shift to ThreadPoolExecutor being the main point on this script here. The reason being, like I said, we can batch we can get a whole batch of ports and run those concurrently. So we have from concurrent futures import ThreadPoolExecutor. Yep. With ThreadPoolExecutor, max workers, assign 100 max workers as executor. Executor map scans these ports between this range, and then executor map is doing the exact same job as the for loop did, iterating over the range, calling scan port for each port, but instead of running them sequentially, in your main thread, it hands them out up to 100 worker threads at once. So it's like basically 100x. I was like confused. I was like, so what is that doing? Like quadrupling or something? Like how much more efficient is it? And it's like 100x theoretically. It says realistically it's a little lower. This is why threading massively speeds up port scanners. Most of the time in each scan is spent waiting on the socket, not doing CPU work. Okay, so same iteration but farmed out across threads equals concurrent. Yeah, I don't even know if because I don't know if I can explain it. Want me to? Yeah. And then so I asked it for more clarification and more of an example. And then so this is before and after the thread upgrade. And then I'm kind of just show this, and then this is what I'm going to get into after I finish explaining this more. So okay, yeah, I'm gonna have to say all this because this is just perfect for me. Anyway, I think I need to re-go over definition or something. I don't know why I don't, because I just got caught up on like making sure I knew what all of this. So I just need to know. Like I am gonna look it up. Okay. But after I say this, so when we call the connect, when we use this connect ex here, it's just sitting waiting for a response or a timeout from the network that is dead time where your CPU is idle, right? And this is based on the question I asked, which is why it's closer to 100x. I was like, how efficient is it? Okay, I still don't think I am. Yeah, I mean, I get it, but like, okay. sequential for loop. This is an example. Port 1 waits, then port 2 waits, then port 3 waits. All that idle time, all that idle time stacks up one after another. Yeah, it does, making it super slow. ThreadPoolExecutor with 100 workers, 100 ports are all in their waiting state at this. They're all in their waiting state at the same time. So the CPU isn't doing 100 times more work. It's just not sitting idle between each one anymore. You're overlapping the waiting instead of doing it one at a time. So the speed up isn't a multiplier like doubling or quadrupling. It scales with how many things you can overlap. Roughly speaking, 100 workers can get you up to 100 times faster, yeah, for this kind of task. Though in practice it'll be less because of the overhead, thread creation, your OS network, you know, yeah. Only being able to handle so much at once. The real number depends on your machine and network, but it's dramatically more than a small multiplier. Oh, okay. It's dramatically. Okay, it's way bigger than a small multiplier. Okay. The technical term for this INO bound work, your bottleneck is waiting on input, output. Oh, my bottleneck is waiting on input / output, not the CPU crunching numbers. So my crutch, not crutch, the thing hindering me is waiting on the input / output, network, disk. Does it mean disk space? Disk quality, network quality, not the CPU crunching numbers. That's exactly the case where threading in Python shines, because Python's GIL, yeah, I forgot, I need to look that up. GIL, which normally limits true CPU parallelism. Okay, so yeah, it's saying Python GIL normally limits, basically slows down the threading process for some reason. So let's look this up now, actually. Python's GIL, Python Global Interpreter Lock. Mutex, or a lock that allows only one thread to execute Python bytecode at a time. Allows only one thread to execute within a single process. Even if your computer has a multi-core processor, the standard Python interpreter CPython forces all threads to wait in line for this single lock. Wow. And I'm guessing there's a Reddit thread that says why Python is removing so why, I feel like it's in place because it's some sort of protection or something, right? All right, well, I mean, that's good. I mean, that's really all we need to know, so we can stop. Both versions. Okay, and then basically based on that information, we should be able to look at this and get something out of it. So let's see. Yep, threading upgrade day 1, and this day 1 is the version sequential loop, which is one at a time basically, and then concurrent a bunch at a time, running either function from. Okay, import socket, import time from concurrent futures, import ThreadPool. Target assigned, swap this for the real, yeah. Port range, yeah, this is the port range. Before, yeah. So this is before. Like I can't, there's no way I could like set timeout. Result assigned to if result is equal to 0, print yeah, but this F string, F, and this is the string here. The string is, I'm guessing whether this is open or closed, but it's open. Port is open, and it's the port. And then you want to close it because otherwise they'll just keep doing stuff, right? Run, okay. Gives me this giant definition for this, but for this, I'm pretty sure it doesn't even say anything. I mean, speaking, because it's just like speaking after the fact, really quick, I should have just looked up sequential. I mean, I see that, yeah. Sequential, whatever, bro. I should have looked it up. Okay. So, yeah, it's just running the sequential scan, of course. It's gonna print a sequential scan. Is assigned to, and we just put a time here, or for in yeah. Time that's went by, yeah. What? Variable. It can have a float. You just put a hyphen, I guess. Oops. Okay, day 2. ThreadPoolExecutor. Scanning the port. I need to look at what that is again, I'm not gonna lie. Because it's like, this is like scan all IVP4 addresses or something like that. And then string. So is it saying like constant or something? Try and see where I asked this question yesterday. Oh, here it is right here. What? Right. So let's go back here to the new. What's new in this from here? Import time, Python's built-in module for measuring time. Start assigned to time, parentheses, grabs the current time as a number of seconds since a fixed reference point. Right before the scan starts, you're not doing anything with this number on its own. It's just a snapshot to compare against later. End equals time, parentheses, grab the current time again right after the scan finishes. Grabs the current time again right after. Okay. We have the end start. That's what I was like, bro. What the hell is end start? What the hell is start? Where did I just see this? Over here? Right here. In start, subtracting gives you the elapsed time in seconds. That's the actual how long did this take number. Right. Okay. .2f. Inside the f string formats the number 2 decimal places, so you get 4.32 instead of 4.3178, blah, 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 blah. Purely cosmetic, makes output cleaner on the screen. Well, isn't that nice? Run. Yeah, and so we want to run this, and then this should be way faster. So this would be like second, 2 seconds, 1 second. This would be like faster than that. Nice. So that's basically. All right. So basically I've figured out that this is a combination of, I mean, I already knew it was, you know, day 1 and day 2, but apparently I could just run these together, I guess. I could just run it right now, and then it'll give me the output of the first one and then the output of the second one. So we're about to see if that works. But first, let's see if these work individually. One's supposed to be faster than the other, so. Is there anything wrong in either one of these? No. Apparently not, so. I'm gonna run this one. What is happening? Oh, yeah. All right. Wait. So is it actually still working? It's just so slow that I'm about to, like, stop it and shut it down.
And it's like over and over again. Good news. Chase Credit Journey can help you with a personalized score improvement plan.
Okay, yeah, let's get out of there. All right, this one should be a lot faster. Let's see about that.
You can even get a Chase Secure banking account with no monthly service.
Oh my god. Oh my god.
Hallelujah.
Wow. All right. Hey, that's Whew. That is freaking good. I'm not gonna lie. All right, well, we don't even need to do this. So these are freaking combined now? So should we just try it? It'll come back up, surely. All right, let's just try it. It's like I get scared that I'm gonna break my entire PC. We're doing sequential stuff. I mean, I guess we'll just wait and see if it does something. All right, there's the second one. We're good on that, bro. I mean, it's not, bro. We're done with this, bro. I mean, that took like 5 minutes or something. I don't know, maybe even longer. All right. I mean, might have took like 10 minutes. I'm not even lying. All right. I mean, that was awesome. I'm gonna like see if I can like cover anything real quick, but that might be it. Cause I mean, there's a lot there. Oh, okay, yeah, I need to go over this. Default target is 127.0.0.1. Localhost. That'll scan your own machine, which is a safe legal target to test against. If you want to point it at something else, for me, it was talking about my Pi or my gateway. Just change target variable at the top, but only scan devices you own or have explicit permission to test. Yeah. Socket time, concurrent features. These are all part of Python standard library. Nothing needs to be installed. What you'll see, it runs sequential scan first, prints the elapsed time. I don't know if it did that. Maybe it did it somewhere else. Hold on, we'll have to look. Then runs the threaded scan and prints its elapsed time. On localhost, the difference might be less dramatic than on a real network. Fewer closed ports, timeouts to wait on. Oh, okay, yeah. Fewer closed port timeouts to wait on. So if you want a punchier before and after video, scanning your Pi or another real device on your LAN will show the threading speed up more clearly. Interesting. Might have to do that. I don't know if it'll be like video stuff, but I'll probably just do it myself. All right, that's cool. Let me see if there's anything else to cover. So I guess some information on, I don't know if this will be the next video. I mean, I'm definitely gonna do it, but I don't know if it'll be. I'm just gonna do it however I want. So I looked up top 10 least expected vulnerabilities documented. I got Rowhammer 2014, Spectre Meltdown 2018, Cold Boot attacks Didn't specify. That was third. Thunderbolt DMA attacks, Thunderclap, Thunderspy, printf format string bugs, dependency confusion, XML, external entity, zip slip, row, level, posts. I'm not even gonna try. MySQL timing side channels in login forms, deserialization, gadget chains, Java, PHP, .NET. And then, you know, I was like, hey, are there any of those that we can practice on? Do a lab on them or whatever, you know? Why not? So the labs that said it was too hard to do would be Rowhammer, Spectre, Meltdown, Cold Boot. These need specialized hardware or, yeah, some other bull. Actually labable. And so I ended up going with Zip Slip and the timing side channel, which was login enumeration. Started with timing side channel login script. Says it's Python native, ties directly into the port scanner that we're already doing. Okay, buddy. Shut. I wonder is the video over or not? 2 ads. So it said it had a timer. I'm not seeing anything. Python native ties directly into your port scanner work and teaches a bug class that's genuinely underused in most junior pen testing training. Nice. The plan is we write a small, deliberately vulnerable Flask login endpoint. Bad version string compares password character by character or bails early on wrong username. Write a Python script that hits repeatedly and times the responses. Graph the timing delta, which is the difference between two values, and see the vulnerability prove itself in the numbers. Okay, you graph the timing delta and see the vulnerability prove itself in the numbers. I see. Then we fix it, constant time comparison, and you time it again to see the fix work. That'd be like, so that would be nice. That'd be fun. That sounds fun. That's basically a ready, yeah. And then I might, we'll build the vulnerability, measure it, and patch it. Want me to build, yeah. And the difference, let's just go over the delta, because I was like, what is a delta? It's the difference between two values. In this case, the difference in the response time between requests. So if a wrong username takes 2 milliseconds to reject, but a right username password, if a right username wrong password takes 50 milliseconds because the server actually checked the password, that 48 millisecond gap is the delta. Because a wrong username is rejected at 2 milliseconds. But a right username, wrong password takes 50 milliseconds because the server actually checked the password. And that gap is also the leak. It tells the attacker this username exists without any error message ever saying so. Without any error message ever saying so. And when I read that the first time, I was like, wow, that's true. Yeah. And so we'll get back into that tomorrow. I'm probably just gonna do some rooms or not some rooms, probably a room. And that'll be it. All right. That works.